All right. Hello, everyone. Let's get started with the next improv show here in the BATS Improv Theater. Well, I wish I did improv, but we're going to do a session at Microsoft Build. I hope you guys are having an amazing build. Day one was awesome. Today is day two. Right after lunch, not sleepy. Let's wake up the room a little bit. So here to get your ideas to production in seconds. So a little bit of energy out there. Hi, everyone. Are you awake? Give me a cheer. Hey. OK. I'm Devanshi Joshi. I'm the Product Marketing Manager for Azure Container Apps. And we will be taking you through getting your agents in production in seconds on an AI-native runtime. And I will be joined by Simon from the Microsoft product team here. Say hi, Simon. All right, and Gopi, our customer augur.
Hello.
So the plan is to cover why agents break between demo setups and getting to production, followed by a live demo on getting you set up from scratch. What are the decisions you take to get that flawless infrastructure to code to deployment to optimization, piecing things together and why they matter, and how Container Apps is actually delivering on these experiences, stitching across all the threads for your agent runtime, with Augur finally coming on stage to highlight this in action in their production. All right, so with a quick show of hands, can you tell me how many of you are already deploying agents in the last 3 months in the room? OK, how many? Keep your hands up. How many of your agents are still doing what you wanted them to do when you deployed them? All right, that's the room. Pretty much 50 to 70% of the hands went down. So Gartner's predicting over 40% of these agentic AI projects will be canceled by 2027. And it's not because of the models. It's because of what you're running, where you're running, how you're running, so the runtime. And one bad tool call that your agent is making brings down your workspace, what you're connecting to, you're restarting, rebuilding, and that cold start throttle in your agent loop. All of this adds to that toil for your execution environment, leading to sometimes even leaks for your data. So every time you're trying to build from scratch, whether you're connecting to existing pieces of code or you're trying to bring in new experiences for your setup, these are 5 things we believe the runtime must deliver on for you to be successful. Not once, not sometimes, but all the time. So first of all, your budget is being burned when left unattended. So someone on a popular news channel actually put it really well. Agents are extremely good at burning through budgets and get even better when left unattended. So the runaway loop overnight can torch a month of your budget for token spent, even before you even notice it, get a hang of it. So next one is untrusted code on your dev laptop. Your agent has access to your environment, which is already hosting your SSH keys, browser cookies, and even your prod credentials. Maybe not the right idea to be doing this on the same machine, right? Then not a sandbox, definitely a liability across all of this. Cold start throttles of your agent loop. There are infrastructure startups right now just provisioning and helping customers for hitting sub-second startup times. So cold start is no longer acceptable at all. Like when your agent is sitting and just waiting for provisioning, that's a big no. 10-second startup was old-time technology. Now we're talking less than 100 milliseconds. That's where we are. And for your workspaces that are dying based on every restart, losing context, cache, intermediate states, all gone. Every restart is paying that environment setup tax. And long-running agents cannot be long-running agents if that floor of context is taken away. Tooling stitched together by hand. Well, every runtime ships its own configs, packaging, its own rules, and porting between your runtimes as you go from development of tooling and agents and all these pieces together. That's another headache to take care of. So none of these are model problems. These are all runtime issues. So it's less about which model to pick all the time, but more about having a reliable experience for your agent creation, hosting, production, observing, and all the time. So the real question is, what would that runtime actually look like? Definitely a fast startup and resume. Agents are event-driven. They wake up, they do their tasks, they go back to idle, they wake up again. So taking that 10 seconds, too much. Nobody cares. It's too hard for the agent to come back on and continue with the user's interest. We leave the window. Cold starts have to be sub-second every time. Not a tuning exercise, not something that you get right on the 5th day. Second, every agent tool calling execution should be easily stitched together with your rest of the apps, the agents, everything all together. So agents are only useful when they are acting, calling APIs, running code, talking to other cloud services. All of that must be inside the runtime itself and not in a fragile glue code experience that just comes on and lights up. Third, persistent store state. So long-running agents, reasoning across hours. All of us would have seen folks running around with open laptop lids, thumbs are at full exercise throttle. So yeah, we need that persistence across. We need the agent live and running. And no one wants to pay the environment setup tax. Finally, the strong isolation for the agent task. Every execution landing across its own fresh sandbox while retaining the security boundaries, preventing any data leaks, any other system leaks, permissions leaks, access leaks, all of that always maintained and always secure by default. Not just at identity level or data level, the access control, what and which systems that your tool calling is connecting the agent to, everything governed together. It's not even at every agent or every project level, it's at the runtime level. And these aren't 5 optimization, they are the spec that you build with. So get them right, and you would not be the 40% that gets canceled by 2027. So with that, I would like to actually invite Simon to take us through building this in action. Simon.
Thank you, Devanshi. Hello, everyone. I'm the guy they call on stage when the high wire act goes. So we will have a high wire act. I'm going to explain some of this today for you first, and then we'll dive into the more exciting part for me, especially the demo. First, this demo is to show many of the features that Devanshi has just advertised. We're going to look at the scalability, the individual sandboxing. We're going to look at the flexibility that Azure Container Apps offers with serverless GPUs and sandboxes. And so I'm going to just walk you through this. Let's first pay attention to this top part. In this top part, we have a Container Apps environment. This is what all of you are very familiar with. Here we run 2 models on serverless GPU. One is Whisper and one is 𝗀𝗀𝗀𝗀. These are speech-to-text as well as text-to-speech models. And then we run a multi-agent broker that basically takes every prompt that comes in and out of every agent and translates it from text to audio. So that's the first part of this demo. And then on the bottom part, you can see all of the agent infrastructure. And so you can see there is a sandbox. We call this sandbox or this agent Aria. It runs Copilot CLI. There is a sandbox called 𝗦𝗲𝗀. It runs Copilot CLI. And then I've also added Azure SRE Agent as well as part of this demo. And there's a series of proxy bridges that will basically go and interface with the multi-agent broker to go in and out with voice to these agents. And then we will interact with this, and this is what I'm going to switch to next, is the browser, where we have this conversation with our agents. And then as extra credit, and this is where I'm really going to be sweating, the phone as well, via the call gateway that was developed and runs on Azure Container Apps by Twilio. So let's get going. And I'm told I'm pushing demo 1. There we go. OK, cool. So here we are. This is our browser view. We have our demos, agents here. And we can just get started. And just to take off the edge for these guys, I'm going to just do a mic check for them. Can you do a mic check? You're actually on stage. Can you say hello to the audience for us? And there is a little bit of a delay.
Hey, everyone. So great to be here with you all tonight. Let's have an amazing time together.
All right. So let's give Aria a job. So there's actually 3 agents. Aria is just a regular copilot/developer for us. We have 𝗦𝗲𝗀𝗀𝗀𝗀, who's a personal assistant. She has access to my calendar, my Teams meetings, and all my emails. And then there's SRE Agent, which actually monitors this application and can tell us about the health of all of this infrastructure. So let's give Aria a job and see how she does. I have no idea whether or not this will work or not. Hey, Aria, can you build a Tic Tac Toe game and tell me the port that it's listening on once you're done? So she's going to go off and do this work. This will likely take a couple of minutes. And while we do that, why don't we ask 𝗦𝗲𝗀 to tell me what important build-related meetings I have today. Hey, 𝗦𝗲𝗀, can you tell me what build-related meetings are on my calendar today? And you can see I could have these doors open and then have just a natural conversation with all of these agents. I can just like literally run this in the browser and kind of keep going back and forth. I find these omni-channel experiences a lot more natural than constantly typing. It kind of feels silly. So this will also take a little while.
Looks like you've got 2 clear build-related ones today. Microsoft Build Expert Shift Calendar Hold, and a couple of Microsoft Build sessions, TECH BRK221 and BRK221. Sounds like a busy build day.
Can you also tell me what my last Teams message was? So you see, these work through the sandbox connectors. Sandboxes natively come with the ability to connect up to an endless number of endpoints, and they can utilize them very easily.
Your most recent Teams message is from 𝗦𝗲𝗀𝗀𝗀𝗀 in the Twilio plus voice 𝗦𝗲𝗶𝗫𝗫𝗫 plus SRE Agent. Chat sent just moments ago, letting folks know that Simon is presenting live at the Build BRK221 session right now.
OK, this was not rehearsed. Anyway, let's ask SRE Agent. Hey, SRE Agent, can you tell me briefly what application you're watching?
You're welcome. Let me know anytime you need help with Voice Connect or anything else. Voice Connect is a real-time, multi-agent voice communication platform. It connects users via WebSocket-based audio sessions to AI agents, including Claude, an SRE agent, and a sandboxed code execution agent. With speech-to-text and text-to-speech services handling the audio pipeline, the infrastructure runs on Azure Container Apps, ACR, log analytics, and I'm here to help monitor, troubleshoot, and maintain it.
All right. So we'll check in with these later. Before we go off, I'm going to ask Aria one more time how the Tic Tac Toe game is going, and then I'll show you some of the infrastructure behind this. Hey, Aria, can you give me an update on the Tic Tac Toe game and which port it's running on? All right. She will eventually chime in. All right. So let's dive into this. This is our...
Great news. The Tic Tac Toe game is up and running on port 80.
Cool. So we'll revisit this here in a little bit. So this is our Azure Container Apps environment. These are all the applications that are running. You can see the workload profiles. If you haven't tried our serverless GPU offering, I highly recommend it. It is the easiest way to run your custom models, anything from Hugging Face via Ollama or any other model hosting container. It's the easiest way to get a handle on GPUs. We offer a set of GPUs, T4s, and a series of A100s, and they're available in 15 different regions. And you can see that these applications are running on these. So here we have the STT application, and then the other one runs the TTS application. And again, this is just serverless, so I'm only paying for this when the application is actually running, and when it's not running, there's a scale to zero event that takes place. Next, let's take a look at SRE Agent. This is a great tool. If you haven't used SRE Agent before, I highly recommend it. In our case, I've wired it up to audio, but you can, of course, see that it is a regular agent. It has a full feature set of all kinds of things, of different connectors. You can connect it to your knowledge base. It can do complete check-ins and checkouts of various pieces of code and so on and so forth. So highly recommended, and we can just interact with it normally here. As you know, we all know. So next, let's take a look at the interesting part of this demo, and we're going to spend most of the rest of this demo on ACA sandboxes. ACA sandboxes are a new offering. They're being launched into public preview. As Devanshi has explained, it is an agent-first platform. This doesn't just mean it is an agent-first platform to run your agent. It is an agent-first platform for agents to use. We're going to go through some of these underlying features that I kind of elevated at earlier. So first, let's dive into sandbox groups. This is a sandbox group. A sandbox group has a set of entities such as connectors and volumes and snapshots and disk images. This is all supported by essentially, so connectors. Inside the sandbox groups run the sandboxes, and they inherit from the settings of the sandbox groups. So what does this look like? I'm going to dive in. So first, let's see, we talked about resume being really quick. And the best part here is actually our resume captures memory state as well. So let's take a look at what this looks like. I earlier, just before this demo, kind of set asleep it's still running, unfortunately. Okay, well, you're going to have to take my word for it. Here we go. We have oh, no, it's not. Okay, cool. So this was a sandbox that I just left running, and I set up a very simple kind of behind-the-scenes script to run, and it continues to run. At the moment, it's not running because the sandbox went to sleep, but I'm going to wake this sandbox up, and you can see it's here. I think this was probably a second or two. And now we can actually connect back to this script and see that this sandbox resumed and was sleeping for roughly 20, 25 minutes right here. And now it's continuing to run exactly like it went to sleep. You can configure sandboxes to capture disk and memory, or just disk when they go to sleep. So that's cool. And now let's take a look at how easy and quick it is to create a new sandbox. We actually have a set of templates already pre-configured for you, and you have to pay really close attention. I'm pushing the create button now, and the sandbox is created. And I can now connect to the sandbox, and I'm inside the sandbox. And if I could spell, I can launch Copilot, and Copilot launches, and the credentials that I explained earlier that were set on the sandbox group are automatically passed into the sandbox, and my Copilot is now authenticated with my GitHub token, and I can start using it right away. All right, next, let's visit 𝗦𝗲𝗀. We already saw what 𝗦𝗲𝗀 did on the browser. Let's go visit 𝗦𝗲𝗀 in the background and see what she looks like behind the scenes. Let's see if I can here she is. And so this is 𝗦𝗲𝗀. And we could launch Copilot here. And we can actually go and see the prior session that we ran. You can see here they are, but we're not going to use that or waste any time on that. Secondly, you can actually see sandboxes are a controlled entity, right? Just like we kind of shared earlier, this isn't just about process isolation. This is also about network isolation. So in this case, you can actually go and isolate all the traffic. You get a layer 7 firewall here that's basically added. And you can control exactly which hosts are allowed, what routes on which host are denied, and so on. And then 𝗦𝗲𝗀 also, as you remember, has access to all of my calendaring and email and Teams. And these connectors right here, again, get inherited from the sandbox group. So because I created 𝗦𝗲𝗀 with these connectors, she has access to my calendar, my Teams, and my email. And that's how she gets access. Let's go and visit Aria. Come on. Sandboxes. So Aria, here she is. And we're going to go, and remember, she developed a Tic Tac Toe game for us. So this game should now be, and you can all like cross your fingers and all that, should be running on port 80. So what we're going to do now is we're actually going to expose this port. So this should be pretty straightforward. We can just say, hey, go add this port. I'm going to add port 80, expose this port. Here's port 80. And hopefully there's a tic-tac-toe game now that I can play. Boom, boom, boom. I missed, unfortunately, a word about autonomous. Otherwise, we could watch the computers play. But unfortunately, that was a missed opportunity. Cool. So lastly, I wanted to show off the snapshots. So because your agents do work that constantly has to be undone and redone, it's very important to kind of snapshot the entire environment, right? Git works great, but really, we all know stuff gets missed all the time when your agents do work. And so snapshotting an entire disk and replaying it or using it as a point of reference to go forward from is always a great process. So here, for example, we can snapshot this trivially. We can create a snapshot. Once the snapshot is created, I can actually use that snapshot to then create a new instance from. So we'll wait a few seconds here. Here we are. D91 is our snapshot. And so in here, we can see, here's the snapshot. And I can create a new sandbox. And before I know it, my snapshot becomes a new sandbox. And I basically have Aria copied. Copilot. And I forgot the resume. So we're going to have to do this. And here are our sessions to prove that this was an exact copy of Aria as she was before. All right, so this is what I wanted to show you, and now we're going to go for the extra credit, which is a little bit of a moment of sweating. Again, this now gives us the call gateway. So we're going to call our agent room, our agent trio. Well, and for some reason, this does not pipe out through the same.
Hi, you are on with the Voice Connect agent. Who would you like to talk to?
Hey, SRE, can you give me the details on the last check-in?
The last check-in was made.
Simon. It's commit 68 𝗬𝗲𝗶𝗫 titled Client. Phase 7 UI polish, which includes a door closed state, drop mode banner, and a new Nova avatar.
Hey, Nova, can you send 𝗦𝗽𝗲𝗀𝗀𝗀𝗀 an email to tell him that the demo went well?
I'm sorry, but I don't have the ability to send emails. I'm an SRE agent focused on infrastructure.
Anyway, I think you get the idea. I think that was the entire demo, and with that, I'm going to hand it back to Devanshi. Thank you all.
How do I go back to the deck?
You pushed it.
Okay. All right. Did you guys blink the eye when he was showing the sandbox creation? Resume, startup? Did you miss it? Did anybody miss it in the room? Okay, thank you for the warning, Simon. That was awesome. Thank you to Aria, SRE Agent, and 𝗦𝗲𝗀 for bringing us together. Okay, so Simon covered end-to-end on how every runtime hurdle was solved, from instant isolation tasks being created with sandboxes to cold starts, the burst that we saw with respect to the scale outs for concurrent sandboxes at creation and scale, serverless GPUs that were provisioned for inferencing, and of course, the snapshotting. I'm sure nobody missed that here. So we have the pre-warm pools available for that cold start in sandboxes and also Azure Container Apps Express. Express is the fast experience for Azure Container Apps that's built on top of sandboxes. And before I go deeper to cover the right side of this table, let me first explain and introduce what Azure Container Apps sandboxes are. The engine that's making all of this demo work. So I'm happy to announce the Azure Container Apps sandboxes, fast, isolated, stateful compute infrastructure on demand, executing securely by default, isolated for all your untrusted workloads, not just AI-generated code, but even extending for your multi-tenant scenarios and more, which we will see shortly. Resuming instantly for all your context, preserving it end-to-end, and of course, bursting to hyperscale, going from 0 to thousands in instant seconds, and dying back down for your idle state without having to get you paying, because all your money is going for tokens, right? So this is the foundation layer that's already powering a lot of experiences at Microsoft itself, like GitHub Copilot's cloud sandboxes that we also launched at Build, Foundry-hosted agent service, and Container Apps Express. Now that I've called out Container Apps Express, just a note, Container Apps Express is fast container apps. So when you are building everything that is not about agents, you would be hosting it on application layers like regular APIs and apps, and that's what you use Container Apps Express for. We already have a lot of interest from customers. Some have tried, tested. Here are some quotes. Something I want to call out, it's not about a particular industry that connects for using Container App sandboxes or the sandbox technology. No matter whether you are an ed tech, you are in services as an ISV, a startup, the experience that you're extending for your existing applications or new experiences that you're bringing out, either an environment you want to expose, like how EdTech does with EdChat from Department of Education in South Australia for a safe experience for every student that they work with, to provide environments to build and test out their technology, and they can work with providing AI democratized experience. Or Sitecore AI, running long-lived agent executions safely, securely through their production environments on their Sitecore AI platform, right, doing real production work end-to-end without losing or doubting control for their agents. We see 6 of these patterns emerging across different scenarios. We saw 2 for multi-tenancy with Sitecore AI. We saw EdTech as a platform for execution of student environments. But there are also agent workflows. That's what Simon demoed for us. AI code executions. So your agent is running. Your agent needs to, based on your task, your ask, needs to execute and build more code and run it. But your agent is part of a production scenario that's already in place. You don't want to risk your production environments. You don't want to risk your data and more. So that's why the agent becomes the user to ask a sandbox to get up, get alive, and go back, die down. Platform building, whether you're a startup, building AI platforms, agent platforms, your own version of copilots, you build them on sandboxes. Or you extend it for multi-tenant ISV experiences, and even interactive user sessions. And with that, let's actually invite one of Container Apps' customers, Augur. Gopi from Augur will be sharing how Augur is building out the supply chain autonomously with agents.
Thank you. Thanks, Devanshi. All right. Let's see. Okay, that's an old photo, but should I point? There you go. All right. First question, how many of you started your career actually writing code? Okay, I would say about 60%. How many of you still write code? See, every time I ask this question, the people who are writing code today is more than the people who started writing code, right? And that's only going to get better because people who basically use agents to write code kind of fake it and say that they write code, and that's what's happening, right? So agents are everywhere, so everybody's writing code now. Like my 15-year-old daughter is writing code, right? So now let's come back to what a supply chain is, right? So when I started out at Augur, I basically went and pieced out the supply chain, and the first example that I picked was literally like that of a pen. I'm sure like most of you, actually this crowd might not, but most of you would carry a pen around. And when you do carry a pen around, like the complexity of that supply chain is insane. Because starting with raw materials, like you basically have all these raw materials. Those raw materials need to get processed into some form of consumable manufacturing parts, like ink and like ball inside the balls of the pen and stuff like that. So everything needs to basically be created into some form or shape. Then it goes to a component assembler who basically assembles those components, and then it gets shipped, stored in warehouses, transport to retail outlets. From the retail outlets, somebody gives that to you, and then it comes to you, right? So that's basically the entirety of the supply chain. Now, we are very finicky people, right? So it's not just, this in itself is very complex. Now, in addition to that, we want a pink pen that writes in blue. We want a pen that basically writes like a pencil. We want a pencil that writes like a pen, and we have a name for it called a pen pencil. And we have all of these insane combinatorics of supply chains that basically make it all the more complex over time. And as that becomes more and more complex, this is just for a pen. Imagine what it would look like for an iPhone or an NVIDIA GPU, right? The supply chains that basically run these are like super complex. And that's the opportunity that Augur is basically trying to conquer using agents. So we're trying to build autonomous supply chains, basically using agents to kind of coordinate across this gamut of boxes in a way that basically eliminates coordination tax. Okay? So I'm going to talk about three specific aspects of Augur. One is it's basically built on what we call as Augur's universal supply chain ontology. I'll come to it why that happens. We are AI native, which basically means that every layer of our stack basically shares the same terminology for agents to comfortably act. And we don't try to reinvent the wheel and try to build foundational models yet. I cannot disclose anything more than that, but there's basically, we are very heavily context driven, because most of the supply chains, there are operators who are sitting inside of these big companies who operated supply chains for decades, and they know a lot of information that is buried inside of institutional knowledge. It's not documented, it's not in public domain. So that context is super important for supply chains to actually operate effectively, right? So the main thing, the first problem that we encounter is that data lives in silos, and unstructured knowledge is basically primarily lost, right? Unless you basically figure out a way to go and pull that knowledge out of wherever the sources are. There is every deployment that most companies do is bespoke, right? So they're trying to pull stuff out of like specific things. They're trying to build a stack vertically for that. So, and that doesn't scale. And then like, there are too many edge cases, and that's basically death by 1,000 cuts. Like this doesn't work, that doesn't work. And then like once you solve like the first 20% of the problem, the remaining 80% becomes edge cases. So these are like primarily like, the data integration issues that we have when we bring data into our system. So what do? We basically build something called agentic data integration, right? So what this does is using ACA, it basically has like thousands of agents that are running across. So let's say a customer comes to us and says, here's a Snowflake account, go and look at it, right? So we pull in all the data, and then we're looking at it. There are 900 tables. Each table has 1,000 plus columns in them and millions of rows in them. How do you make sense of this data, right? Like a human team trying to actually organize and make sense of this data would take forever. A single deployment to a single customer would probably take you like, 12 months at least to even start making some progress. So what we do is we basically build an agentic harness. This harness goes and figures out all of this data. It figures out what each table semantically means, how it is related to another table, how the column features look like. It basically creates a whole sequence of information, and this information then percolates to the higher level agents, which are now reasoning and joining these tables and predicting how these tables interoperate amongst themselves. And final layer of that is a human in the loop system. So this is where like, for the long running agents to sleep and then for them to wake up through like, a human in the loop approval workflow and like an information workflow, collect the context, bring it back into the system, use that context to do the next level of work. And this entire process basically is completely agentic, which allows us to literally like take 1 year of like, a data integration system and run it in days. So the second one, that without a world model, like agents basically break. If you say that I'm going to hyper customize every single supply chain problem into a specific solution for a user, we'd be building solutions like 1 year every day, every solution. It just doesn't work. So in order to do that, what we have built is something called OSCO. It's an Augur Unified Supply Chain Ontology. When people talk about ontology, usually they talk about data schema. Ours is much richer than a data schema, which means like, it has codified into it like, common mathematical operations, common functions, the physics of how a supply chain operates, how products move, processes, buffers, and everything. All of that is codified into the system. So we try not to do deterministic stuff with agents, and we kind of split that apart. So which means agents basically do the decision making, they do the reasoning primarily, and then the deterministic stuff always happens within like very strong deterministic blocks, which are available as tools for those agents. So that world model now scales across multiple customers. So we have the data first, we have this world model, we need to somehow connect these two. And that connectivity is what we refer to as the bus, right? So the world model is there, we bring in the data, and because our ADI system is completely aware of the higher level layer that it needs to report into, it connects all this data, automatically builds all the ETL pipelines, automatically builds the machine learning notebooks. It does all of this stuff and connects all the data coming in into interoperable, useful intelligence that then connects into our OSCO layer. Once the OSCO layer is connected, then on top of it, we need to add context, right? On top of that, we need to add context. So the context is important because this is specific to how every company makes decisions. What is important to them? Like, they have tier 1 customers, they have tier 2 customers. Tier 1 customers can never go hungry. Tier 2 customers, it's okay if they starve a little. So those are all decisions that like, are contextual information that is buried inside of every company. We need to be able to take that and pull that in real time. So far what you saw, the first 2 slides that I presented to you, was primarily around like, offline workflows that use thousands of agents to actually come to a solution. This one is actually a real-time workflow. What that means is when a customer basically comes in and says that I want to ask a specific question as to what happens if I put a warehouse in this specific location, that's a what-if scenario. We need to run through like a modeling pipeline, a simulation pipeline, and get the results to them. But in order to do that, we need to parameterize that pipeline. We need to identify the right input information that goes in and push it into it. Doing all of that stuff in real time requires like very fast ACA agents that can basically open up sandboxes, run it, send it to like, other agents. They make their local decisions, they pull the data, all of this happens in a matter of 10 seconds, right? So that level of reasoning and speed is super critical for the real-time experience. So the back-end experiences can take time, but they are long-running events. The front-end experience are like really fast, right? So that basically leads to my final slide, which is over like till March of last year is when we started writing the first line of code. And thanks to ACA and Azure and Azure Foundry, we basically have like closed on like publicly to customers today, right? So that's the speed at which we are able to develop an enterprise level solution at scale. And we have 40 plus services that are literally running on Azure Container Apps. And we have thousands of agents that are running on top of it on a day-to-day basis, right? So that's the autonomy that we are building into the supply chain system. Yeah, that's it. Thanks, Devanshi.
Thank you, Gopi. All right, so we're in the final leg of the session. Let me leave you with 3 things. First, container apps, as we saw with Augur's demonstration from Gopi, is delivering that cohesive agent runtime already for customers in action, apps, sandboxes, everything put together. And container app sandboxes are now in public preview. And we are not just exposing things for our customers to try out. We are using it ourselves. Microsoft is building on top of our own technology at the speed of innovation that we are delivering them for our customers itself. So GitHub, Foundry, container apps, and other Azure services are also using the same agent runtime experiences, building agents and delivering agents for our agentic experiences for our customers. For you to get started, you should check out the Azure Container Apps All Up product blog. The demo that Simon showcased today, the code is available here in the code repository. And as you go out, you can access the sandboxes portal in aka.ms/ACA/sandboxes, and then /portal for the direct access to portal. There's a blog with samples for you to already get started end to end, and of course, Express too. Now, with that, I'll take a pause, open it for at least one question in the room before we are cut off, but let's bring back all the speakers. Simon, Gopi, join me. Any questions? Yes, please. Can you please give him the microphone?
Oh. The code.
Yes. Okay. All right, how about now? Let me give you some space. Okay. So as folks are taking on the code sample, Simon, do you want to talk about what and why Express and when sandboxes?
Sure, yeah. Maybe there is some confusion about that. So sandboxes are a fast iteration environment, right? They are built for agents to be used, to run agents, but also for agents to use in their development. And then and so they're very transient in their nature. In some way you can think of them, if you've ever run with your laptop through the airport, like still open because you're finishing up, you're having your agent finishing something up. In some way, both of the sandboxes are basically your laptop, and then Express becomes the thing that you deploy to. Express is similarly speedy. We didn't really have the time to go and dive into that. We launched that about a month ago. Express is kind of the best of container apps. It is a environment-less. There's no more, physical cluster behind it. It is essentially just an app, the best for web apps. So you deploy on Express, and you develop with your agents on sandboxes.
Okay. With that, any questions out there? Yes, please. Can we please get him a microphone?
Thank you. This is Gopi. First of all, I'd like to understand which layer does your OSCO world model stand on, right? So, and what format is it? Are you hosting it in a markdown, or is it running in an agent in itself? A bit more on how you are doing it.
It is actually code. It's actually an object-oriented representation inside of our code. And because like we want as much as possible as to be deterministic, but our agents are actually registered with OSCO as well, right? So every agent is registered with OSCO, every object, so the data schema is also OSCO, common functions are OSCO, everything is registered in there. So it's basically like, think about it as the world model, not just in terms of data, but in terms of how supply chains operate. Right?
Okay, we're at time. Thank you so much for joining us, and have a great rest of the build.
See y'all.